should be good for now. Alright, we can just hop right into it because this is a pretty simple one. So welcome back to Programming Challenges. Today we're going to be looking at string streams in C specifically, not C++. So in C++ you have your, there's a standard library class, the std string stream, and you can do all sorts of shit with it. It's pretty cool, but in C there is no, there's nothing like that. So in this video we're going to kind of create a structure for that in C that will also kind of mirror as a standard string in C, because this will be you can concatenate to it, do whatever you want with it. So we are going to go ahead and start with just kind of an overview of what we're going to have here. So, oh, I need to connect my drawing tablet. Give me a second. There we go. And we are looking good. Okay. So what you're going to see is that when we, the structure that we're going to use for our string stream is just going to be a string, which is pretty much how all string streams have it, or that is how all string streams are represented. But our addition to this, or the thing that will make it resizable, is the addition of a counter for both the capacity and the size. So let's say we have an initial size of just 4. So 1, 2, 3, and 4. So the size is 0, capacity is equal to 4. Now this may remind you of the dynamic arrays video, and we're going to essentially use the exact same structure as a dynamic array. We have an array of elements. We have a capacity and the size. The only difference is our array will be an array of characters. So these are all characters. And since they're characters, we can take advantage of so many of the functions that exist in the printf family. So we're looking at scanf, stuff like that. Or no, actually it's just going to be printf. Not scanf, but we can format strings, we can do all that, and we can read it in dynamically with an unknown size to the string stream. So let's go ahead and start with an example here. So we start off with our initial array, and it has a terminator character at the beginning. All right, and then let's say we wanted to add a string A, B, C, D. Yeah, A, B, C, D. So this is a string of length 4. So the new size would be 4, and the capacity would be equal to 4. So you might think, okay, this is good. However, we need a terminator character in there. That is required. So this thing right here, that is a must-have, because if you want it to function like a string, it needs a terminator character. So we're going to have to resize it to an s equals 4. Size stays the same, but the capacity is multiplied by 2 to 8. So then we have 8 boxes. 2, 3, 4, 5, 6, 7, and 8. So then we insert our string ABCD and then \0. All right, let's try. So once again, we see the terminator character, and notice how the A is written at the previous position of the terminator character. So we will start writing at the current value of size, which is also the position of the terminator character. So we go 0, 1, 2, 3. So we have 4 characters, which is the size. So that's 0, 1, 2, 3. And then at the index size, we put the terminator character. Then let's say we wanted to add, let's add a 3 character string. So EDF, or not EDF, EFG. Don't worry, I know my alphabet. EFG, which is a string of length 3. So therefore we have size equal to 7, capacity is equal to 8. This is valid, we don't need to resize. So we have A, B, C, D, E, F, G, and then \0 for our terminator. And then let's just say we wanted to add one more character, H, which is just a character of length 1. So once again, size equal to 8, capacity is equal to 8. So since they're equal, we need to resize to a capacity of length of 16. So size is now equal to 8, capacity is then equal to 16 multiplied by 2. And then we get 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So then we have our string A, B, C, D, E, F, G, H, and then our terminator. So if we wanted to print this out in printf, it would read up until the first terminator character, which is A through H with the terminator there. Alright, so yeah, this should be pretty straightforward. There's just a few new functions that we'll look at that we haven't really looked at before, such as reallocate. And then also we will look at some of the other advanced memory methods that we have seen before, such as in the MP3 file one. We looked at some of these, but it's going to be a good kind of combination and an implementation in C. Alright, so let's start in a new folder. I just have my debug and run batch files here with just 2 source files, main and strstream. And let's go ahead and create 3 files. We're going to have main.c. We'll have strstream.h. Oops. And then strstream.c. Alright, good. Alright, we'll start in the header file here. And we will have some includes and macros to start off with. Alright, so include is going to just be an stdio.h for now. Well, that's actually going to be it for the header file. And then we'll have our macro, so if not defined, strstream h, define strstream h, and if. Then we're going to have a macro here, define strstream default size, and we will do 1 left shifted by 2. So this will be equivalent to 4. Alright, then we'll have our structure here, so type def struct strstream, and then we will just call it strstream at the end. And then in here we'll have the pointer to the character, so character pointer str, then an unsigned int capacity, and an unsigned int size. So once again, the capacity represents how much space is allocated to the string, and the size is just how many characters are actually being used at the current moment. Alright, so we'll go through a few function signatures first. We'll start with allocation. So we'll have one that returns string stream, str. I'm just going to have the same kind of tag, but it's not relay tag, it's just the same first word in the function name, strstream, alloc for allocate, and it's going to be taking an unsigned integer size. Then str return type string stream, and we'll say allocate default. This will just take in the default size. Then return type string stream. We will then allocate from string, or just do from str, and we'll pass in a character pointer str there. All right, then we can copy these signatures over, and then in str stream.c we'll copy them over, but then we also have to have some includes. So we'll start with include str stream.h, include stdio.h, include stdarg.h, include string.h, and then include stdlib.h. So we're going to need functions from all of these. The stdio will be for files and printf, stdarg will be for a variable argument function, string will be for some string functions, and then standard lib will be for the allocation. All right, so we'll start in alloc. We will first create our placeholder, so str, I'm just going to call it string stream, but I shorten the name to str string. So string stream ret, just have, and then semicolon, ret.size equal to 0, ret.capacity is equal to 0, and then we want to kind of create a capacity that will be able to hold the size, and it has to be a power of 2. So we'll start with unsigned int capacity is equal to 1, then while capacity is less than size, we will say capacity left shifted equals by 1, so just multiply it by 2. Alright, then we're going to allocate, so ret.str is equal to malloc capacity times the size of a character. Alright, and then we'll check to make sure everything was allocated properly, so if ret.str, and if it was, we're going to say ret.capacity is equal to capacity, so update that so we can write to it, and then we're going to set the terminator character. So ret.str at ret.size is equal to \0. Or we can actually have we could have a function here. Yeah. We could have a function just to do this termination here because we're going to be doing it several times. So I'll create a new group of functions in string stream.h. I'll call it modifiers. And then this one will just be void string stream terminate. And we'll pass in a string stream pointer s. Alright, and then then we can paste this signature over. And in the function body, all we're going to have is if s.capacity, so we just need to make sure that there is space allocated, or if s.str and s.capacity, then s.str at s.size is equal to the 0 terminator character. And then we can call this function in allocate just by calling string stream terminate and pass in a reference to ret. Alright, and then after the if statement, we're just going to return ret. So if the string was not allocated, then capacity will remain as 0 as we set it, and size will be equal to 0, and we will have no memory to write to. For allocate default, we're simply going to say return string stream allocate and pass in the macro string stream default size. And then string stream from string. This is going to be pretty straightforward. We're going to get the size, and then we're going to allocate it with the size, and then copy the memory over. Doesn't like this. Oh, there we go. So from string, we're first going to get the size. So int size is equal to string length, strlen, from the string header, and we're going to pass an str. Then we're going to get the placeholder, so string stream ret is equal to string stream allocate, and pass in size as the desired size. And then if ret.capacity, so we're making sure that we have stuff, then mem copy, pass in ret.str, str as the memory, so we're copying from string to ret.string, and the number of elements will be size times the size of a character. It's not necessary to put the time size of character here because that's just one, but just for correctness and readability, I'm going to put that there, just so we're not just passing in a random integer. And then we can set ret.size equal to size, and then return ret. All right, so those were our basic allocation functions, and now we're going to have a reallocation function. So this is going to return a character, just because we don't have access to a boolean right now, and it's not that necessary to create a type def here. So we'll say character string stream reallocate realloc, and we'll pass in a string stream pointer s and an unsigned int additional length. So we're gonna the function here is telling us, okay, we want to make sure that we have enough space in s to account for this additional length here. So I'm going to copy this signature over, and the way we'll start is we're going to be getting the new size if we were to add the additional length. So unsigned int newSize is equal to s dot size plus additional length. Then if newSize plus one because we need the terminator character again, remember that, is greater than s dot capacity. So if there's not enough capacity to account for the size, then we want to get the required size. But first we want to check to see if the capacity is 0, because that is a possibility. So if not s dot capacity, then s dot capacity is equal to 1. Then we're going to say while s dot capacity is less than newSize plus 1, s dot capacity left shift equals by 1. So that's just we've seen this stuff before in the allocation method here. So we're just left shifting until we get the proper size. All right, and then we want to reallocate. We should actually have a temporary variable here. So unsigned int capacity is equal to s dot capacity, and the reason why is because allocation might fail. So we don't want to set the capacity in the string stream until we know that we have allocated new memory. So if not capacity, then capacity is equal to 1, and then while capacity is less than newSize plus 1, then capacity left shift equals by 1. So just remove the s dot from all those there and create a local variable. All right, so for the reallocation, we're gonna get some memory. So char pointer new mem is equal to reallocate, and we're gonna say s.str s.capacity times the size of character. So what reallocate does is it takes the string, the pointer, so we want to copy from character 0, and we want to copy the capacity. Or we want to, this should be capacity times the size of a character, not s.capacity, because capacity is the new size that we want to allocate to. So what reallocate will want to do is it will try and see if there is available memory in the same block that it's in currently. So if there's contiguous memory, and if it's not, then it will then it will return a null. So we need to reallocate in a new location, and it may also return a new pointer where we just need to update the pointers in the string stream. But it will if it copies it over, or if it finds a new location and then allocates the sufficient memory, it will also copy over the memory of s.str. So if not new mem, then we must allocate a new location. So new mem is equal to malloc, s dot or capacity times the size of a character. Make sure it's the local variable capacity since that's the updated size. Then mem copy, so we're going to copy over new mem. The source will be s.string. s.capacity times the size of a character will be, or this should also be capacity times the size of a character. Sorry about that. So the parameters for mem copy will be the destination is new mem, the source is s.str, and the size is capacity times the size of a character. Then we're going to free the existing string, so free s.str, and then we're going to update the pointer. So s.str is equal to new mem. So just like that. Oh. And we're freeing the current string just because there's no use for it anymore, because it's the updated string will go in a new location, so we just want to free the memory. Now else if new mem does not equal s.str, so the pointer has been updated, so reallocated in a new location. So free s.str. We're first going to free the string because the memory has been copied over. So essentially this step right here has been copied. And then we're going to say s.str is equal to new mem. And then otherwise, new mem is equal to the string. So it's the memory is just still there, so we don't need to update any pointers. And then in the outer if statement, so still within the if newSize plus 1 is greater than s.capacity, we first have to then update the capacity. So s.capacity is equal to capacity, and then return not 0, so returning true essentially. And then otherwise, so in the outer function block, we're going to say return 0 for false. All right, so that's reallocate, and we're going to call this function many different times here. All right, let's head back into the header file, and we're going to create some new functions. So we'll first start with a new group called the accessors. And this will just be one function. It will return an unsigned integer, and it will be string stream available. So this will just return the amount of characters that are available. So and we'll just pass in a string stream pointer s. All right, so I will paste this into the source file, and then all we're going to do is we're simply going to return s.capacity minus s.size minus 1. Once again, the minus 1 because we need space for the terminator character. Yeah. All right. Now back to the header file. We're gonna have 3 new modifier functions. So it'll be void string stream concat. So we will pass in here a string stream pointer s, a const char star format, and then variable arguments denoted by a ... So this is going to be where we call printf, because, and look at it, format will be the format, and ... are the arguments, except we're not outputting to the console, we're going to be outputting to s.str, and we will see how to do that. Then we also want to void string stream read, and this will just, we'll take in a string stream pointer s, and this will just read in from a void pointer data, and it will read unsigned integer length number of bytes. And then last function will be void string stream retreat, and we will pass in a string stream pointer s and an unsigned integer length. So this will just retreat the cursor length number of bytes. All right, so let's copy these 3 signatures over. All right, so now that we have written the reallocation method, all of these functions are going to be pretty straightforward to write. When I did this on my own, I kind of implemented reallocate in like 3 or 4 different ways, and then I realized how stupid that was because that just took up so much space in the file. So I just figured, why not just put it in a separate function and make it, and then deal with the output separately. All right, so in concat, we first want to get the variable arguments. So we're going to use the std_arg header file, and we're going to say va list args, and then we say va start. We'll start the args list starting after format. So format is the parameter just before the arguments that we want to get. All right, then we're going to do unsigned integer available is equal to string stream available. So we're going to call that function, pass in s, it's already a pointer. Then we're going to call a function vsn printf. So vsn printf. So what does this mean? So I'm gonna walk you through the three letters in the front here. So we know what printf is. It just prints out to a string. V denotes that we can take in a variable list, because we can't just pass in a ... That just doesn't work like that. But we will be passing in a variable list, and this function is designed to take that. And then we also have an S, meaning we want to output it not to a console but to a separate buffer. And then N will be for overflow protection. So we have a cap on how much memory we have available left in the buffer. So vsn printf, the arguments will be s.str plus s.size. So we're doing a bit of pointer arithmetic here, where we're taking the string, the 0th character, and we are adding s.size to it. So if we go back to OneNote, when we had A, B, C, D, and we added EFG, we don't want to write at 0. We want to write at character 4, which is the size. So we go the pointer, which is the pointer at 0, plus the size, which is 4. So s.str plus s.size for the buffer. The second argument will be available. So that's just the amount of characters available. And I should actually do available times the size of a character. Once again, just for readability. The format will just be format, and then the arg list will be args. So the args that we read from over here. All right, so this function, what do we do with this? So we don't know right now if this is overflowed, because we could pass in some long ass string and we wouldn't know. This function does return a value that will give us the actual length of the formatted string, even if it overflowed. So we're going to get an integer return from this value. Or I'll call this format size. So int format size is equal to the vsn printf call. And then we will end the list here. So va underscore end args. All right, then if string stream reallocate, so if we did reallocate memory, and we're going to pass an s, and the additional length will be format size. So if we did reallocate, we want to read in the formatted string to the reallocated block. So why do we want to do this? Haven't we read it in already? Once again, just remember, this has overflow protection. So if we look over here at when we added A, B, C, D, what happened was we added the 4 characters and it read it in properly. And so the A, B, C, D existed. However, there was no space for the terminator character. So therefore, we're reallocating. But this, let's say that there was an extra character here that would go into this to the reallocated block. So let's say we had like an E in the first addition. So the E would be in position 4 and the terminator would be in position 5 over here. So therefore, the E would not exist in that initial string that was read into. So we need to read, we need to reread the formatted string to the reallocated block. So the way we're going to do this is we're going to say, we're going to get available. Once again, the updated value for available is equal to string stream available. Pass in s. Then we want to get our arguments again. However, we can't just pass in args. It's not as simple because we need to restart the list because we've already iterated through it in VSN printf. So va start, pass in the same parameters args and formats as the parameter just before the list. And then ret is equal to, we can say format size is equal to VSN printf, the same parameters. s.str plus s.size, available times the size of a character, format and args, and then va and args. All right, and then after this, even outside of the if statement, we're going to want to do this no matter what. So s.size plus equals format size, just so we can update the size, and then we want to terminate, so string stream terminate and pass in s there. And this function here does, the terminate function will do no error checking at all, so we're just assuming that there's space for it. And we do know that there's space for it because we've reallocated everything. Okay, now for read, it's going to be pretty simple, or somewhat similar, just actually a lot simpler because we already know the length of the data. The problem with concat was that we didn't know the length of the formatted string because there are potential arguments. So a formatted string example would be like %f or something like that. And this string, if we just read it in, would have 5 characters. However, if we pass in parameters as 15.21f and 89.23f, this would take at least 9 characters because we have at least 12 characters. Because we have 15.21, which is 5, 89.23, which is 5, and then we have the 2 in the middle, so that would take at least 12. So we don't know the length initially. So this function will be easier to implement. So we're going to call reallocate right off the bat. So string stream reallocate, pass an s, the additional length will just be length. And we don't need to check if it was reallocated. We don't give a shit. Because we just need to know that the memory has been allocated because, and the reason why we don't care is because we don't need to reread anything in again. So we're just going to read it after this no matter what. So we're going to copy the memory. So memcopy, pass an s.str plus s.size. Once again, same shit. Same logic for the pointer, arithmetic, and then the data will be the source. And the size will be length. And then same as above, we want to update the size, so s.size plus equals length, and then string stream terminate. Pass an s right there. All right. For retreat, we're going to have a pretty simple error check. So if not s.size or not s.capacity, we cannot retreat any further. So just return. And then outside of this if statement, we're going to return at the beginning if the length is too long. And then otherwise, just move move the cursor back length positions. So s.size is equal to length is greater than or equal to s.size, question mark 0, we're doing a ternary operator here, then colon s.size minus length. So I've been talking a lot about cursors. Our cursor the size attribute of the structure here is kind of has two uses. It tracks the size one, but then it is also kind of our cursor. Because think about it over here. Our size is 4, and that's where our terminator character is, and that's also where we're going to start writing, be after that, which is cool. So yeah, that's going to be that. But the operation here, we're just saying if the length is greater than the size, then we cannot go back any further. So we're just going to go to the beginning. So we just set it as 0. Otherwise, we're just going to subtract length from the size. And then we want to set the terminator character. So str stream terminate s. All right, one more function, and then we will do some testing. So this function here will be just a clear function. So void string stream clear, pass in a string stream pointer s. All right, let's copy over the definition or the signature. This is going to be pretty straightforward. We're just going to free s.str. Let me scroll down a bit here, and then set the size and capacity to 0. So s.size is equal to 0, s.capacity is equal to 0, and then we're done. All right, just like that. All right, let's do some testing now. So let's head into main.c, and we will include a few things. So we'll include string stream.h, and then we will also include standard IO. All right, in main, we'll just have a return 0 here, and then I'll just do a printf hello world just to make sure everything works. I'm going to call it run batch file, and hello world, perfect. All right, so let's do our thing now. So we're going to create our string stream structure. So str stream s is equal to string stream allocate defaults. We'll just do that for now. So I'm going to print out, I'll print out a few things here. So we'll do a %d, and a %s in quotation markers. And we will print out the size, so s.size, s.capacity, and s.str. So I'll reuse this function a few times, or this print statement here a few times. All right, we'll try concatenating. So str stream concatenate, pass in reference to s. The format we'll say is, let's see, what do we have over here? So let's just try with ABCD, just to make sure everything works. So ABCD, and no arguments needed otherwise. We'll do the same print statement, and then we will clear, so string stream clear, pass in a reference to s, and then return 0. So if we run, we see we get a 0, 4 initially with an empty string, and then a 4, 8 in ABCD, which is exactly what we want. All right, let's try doing the other shit in here. Let's try, or let's try putting a formatted thing in. So we'll do str stream concat reference to s. The format we'll say is my name is, and we'll pass in a string here, and we'll also put a new line at the end, or a tab rather. And what do we want the name to be? Let's make the name what should we make the name? I'm just looking at shit on my desk right now. Or I have a mask on my desk, so I'll call it face mask. Like that. Alright, and we'll do the same print statement. So run. All right, so let's see. We have a length of 24, capacity of 32. That checks out, and then ABCD. Then my name is face mask as expected, and then we have the tab. Let's try putting in a super long name just to show you that it will reallocate based on how long the formatted string will be. So just do that. That should bump it up. And we get a 47 to 64, so it reallocated based on how long the formatted string would be. Alright, so you can play around with this for a bit. We're going to move on to working with files, and it's just going to be two methods that we will just do just to have some added functionality to be compatible with files. So file IO, we'll have a void string stream, read file, pass in a string stream, pointer s, a file, pointer file, and an unsigned integer length, and then a void string stream, write file, pass in string stream pointer s, a file, pointer file, and an unsigned int first and unsigned int last. Alright, so for read file, parameters will just be how long you want the file to be, and we can say, if you pass in a 0, just read the entire file. And for write file, we'll just do first and last, and if you pass in a 0 for last, we'll just go from first to the end of the stream. Alright, so I'll copy these signatures over, paste them in. Alright, we'll start with the read file. Alright, so then we first want to get the file size. We first want to do our input check. So check if length is equal to 0, which means that we want to read the entire file. Or read to the end of the file. So if not length, then read rest of file. And to do that, we need to get the size. The way we're going to do that is we're first going to mark the cursor position in the file. So int previous is equal to ftell file. So that just gets the current position. Then we're going to seek to the end. So fseek, pass in file as the pointer, 0l, and then the origin will be seek end. So just means move cursor to the end. And then length is equal to ftell ftell of file, so get the current cursor position and subtract the previous. So if previous is 0, then we're getting the entire length of the file. And then we're going to seek back to the original. So fseek file previous and seek set. And this, so just return to previous, or return to original cursor. So this is the part that we looked at in the MP3 files, where we needed to get the length of the file, so we just went to the end, determined what cursor position that was, and that was the file size. Here, we may not be getting the entire file size, we just want to get from the current cursor position. Alright, now that we have a determined length, it's going to be just like reading a void pointer data. So we're going to say string stream, reallocate, s and length. So because we have the determined length, then we want to read from the file. So fread, we're going to read from s.string plus s.size, same logic there. The element size will be size of the character. The number of elements will be length, and file will be the file pointer. So this function here, fread, is good for reading units of memory into structures or arrays of structures. We also used fread in the MP3 file, or in the MP3 challenge. All right, then we want to increment the size. So s.size plus equals length, and then terminate. So string stream terminate, pass in s as the reference. For write file, this is going to be 3 if statements and then 1 write statement. It's going to be relatively simple. So if not last, write to the end of the stream. So last is equal to s.size. And if last is greater than or equal to first, then we want to say if last is greater than or equal to, if last is greater than s.size. So the outer if statement here means we just want to determine if the last and first can cooperate properly, and we won't get a negative value or some massive value after subtraction overflow of a negative value in an unsigned integer. So otherwise, we're going to say if last is greater than the size. Then we just want to say last is equal to s.size, and also do the same check for first. Or we can also just put I'm just doing this with no direction right now, but just have a few checks here. So if in the beginning of the method, we can say if first is greater than or equal to s.size, then we're going to just return, because you can't write something that's not there. And then I'm sorry, but these checks are really unorganized. So this is just ensure first index in bounds. And then we're gonna determine to see if make sure last is after first. And then inside that check, we're going to ensure last is in bounds. And then after this if statement here, we're going to say fwrite, so this is the actual function, and we're going to write from s.str plus first, so pointer arithmetic, get the first character that we want, and the number of, or the element size will be a size of a character. The number of elements will be last minus first, which is just the range, and then the output will be the file. So all these dumb if statements just for a single fwrite. So let's go ahead and test this out. I'm going to create a test file here, test.txt, and I'll put some gibberish. Just like that. So I should expect to see this when we're done. So we'll go into main.c now. You can just put whatever you want in a test file, and I will delete, or I will just comment out the existing stuff that we have, and then instead I will go ahead and say string stream, or we need to open up a file first. So file pointer fp is equal to fopen, test.txt are the path of your file, and the mode will be RB for reading in binary, since we're reading in just binary data. And then we can say string stream read file, pass in a reference to str, fp is the file, and the length will be 0 since we want to read the entire file. Then fclose fp, and then we want to print out, so I'll just use the same print statement over here. Alright, let's run this, and we get the file contents, which is exactly right. Alright, let's try concatenating and then writing to another file. So we'll concatenate the other set that we had, and then string stream write file, or we need to open up a file first. So fp is equal to fopen test2.txt. The mode will be wb for writing in binary. Then we'll write, call string stream write file, pass in a reference str fp and 0 0, since the first index is 0 and we want to write to the end of the stream. And then fclose fp. Alright, so let's run this. Alright, so it seems that everything was allocated properly. We had the initial file contents, and then we have whatever the fuck we added, which was this garbage over here. Although I don't know where this, oh, the backslash g came from here. Okay, that makes sense. Alright, let's check out test2.txt, and we should see the same stuff. Et voila, it's done. Alright, yeah. This was kind of a half-assed video. I know, I did want to do this because I was working on JSON in C, so I did need a string stream at some point, and I didn't want to just give you guys a class without explaining it. So there's this stupid little video, but this could help you if you need. Yeah, that is string streams in C, which is such an exciting topic. But there's some interesting memory things in here. We look at the pointer arithmetic, which is kind of cool. And we also look at the C file IO methods, which are also somewhat interesting to look at. So yeah, this was, once again, I'm sorry for the half-assed video, but I didn't want to throw something on you without any explanation. So this has been string streams in C. What's up, Deeks? Yeah, popped in at the end. Yeah, so that's about it. I hope you learned something. I mean, it's somewhat straightforward, but maybe you learned something. Maybe you did, maybe you didn't. I hope you did. Anyways, stay safe, and I will hope to use this in the JSON video at some point. But until then, I will be working on that. So take care of yourselves, and I'll see you then. Have a good one.